A random sample of 105 light bulbs had a mean life of 441 hours with a standard deviation of 40 hours. Construct and interpret a 99% confidence interval for the mean life of all light bulbs of this type. It asks us for a 99% confidence interval, and it's talking about the mean. Since we are dealing with a mean, we have to determine, are we going to be dealing with a t distribution or a z distribution? And looking at the information that's given, it tells us that the standard deviation is 40 hours. Specifically, it tells us that sigma is 40 hours. Remember that sigma is your population standard deviation, and S is your sample standard deviation. Therefore, we are going to use a normal distribution or a z value, a z critical value in this problem. Step 1 is to determine if our conditions are being met. In this case, we want our sample to be random, and we want either our sample size to be greater than 30 or to be normally distributed. Our population specifically to be normally distributed. And is it random? It says a random sample, so that has been fulfilled. And our sample size is 105, which is greater than 30. Therefore, that is taken care of. Step 2 is to identify our critical value. We said we're going to use the normal distribution, so we need a z critical value for 99% confidence. So looking at our chart here, 99% confidence level has a critical value of 2.575. This is going to be 2.575. And then step 3 is to calculate our margin of error. Our margin of error here is going to be our critical value times our standard deviation divided by the square root of n. Our critical value was 2.575. Multiply that by 40 over the square root of 105, and we get that E value (2.575 times 40 divided by the square root of 105 leaves us with 10.05177 approximately. And from there, we can build our interval. Now, step 4 is to build that interval. We're going to take our point estimate, which in this case, our point estimate is x bar, and subtract away our E. And we're going to take our point estimate and add E. We get 430.9, so I'm going to round this to 431 hours. And when we add again, we get 451.05, so I'm going to leave it at 451 hours. Our interval then in this case is going to be 431 hours is less than the population mean, which is less than 451 hours. And our final step then is to write down our interpretation. So step number 5, we would say we are 99% confident that the interval from 431 hours to 451 hours actually does contain the true population mean.